So guys, welcome back. Now in this section of the course, we will going to learn about thread pools. So thread pool is all about parking your threads in the garage. So imagine you are super rich and there are a couple of servants always in the ready state waiting for your next commands to do your work, right? Life will going to be very easy for you, right? Perhaps every one of us may have dreamt of having such a luxurious life at some point of time. So thread pool is all about implementing this particular analogy, right? All the source codes related to thread pools can be found in this following directory, that is section thread pools. So going forward, a thread pool is a parking space of blocked threads which are in a ready to use state or in a ready to resume state. A thread pool can be modeled as any data structure. It could be a list, it could be a tree, etc., which can hold thread objects. Right? So in our thread library, we have been representing a thread using this thread data structure. So any data structure which could be a collection of these threads could be termed as a thread pool. You can model thread pools as a list or as a tree or as any other data structures which can hold the objects of type threads, right? So there is no hard and fast rule regarding what should be the appropriate data structures which represent your thread pool. Depending on the problem statement, your thread pool can be modeled as lists or trees, right? A thread in a thread pool is in ready to use state. Just like you have your cars parked in a garages and they are in ready to use state, right? So when a thread is present in the thread pool, at that point of time, your thread is actually blocked on a condition variable, right? A thread which is present in the thread pool is obviously not an executing thread, right? It is not executing its execution flow at that point of time when it is present in the thread pool. It simply means that the threads have to be in the blocked state to be present in a thread pool. So it translates to that the thread is blocked on the condition variable when present in a thread pool. So when application needs to do some amount of work, let's say that amount of work is W, the application simply picks up the unused thread from the thread pool and assign the work W to the thread and signal the thread, right? Here signaling the thread means making the thread to execute, right? Now this thread which executes perform this work W on behalf of the application. So you can see that application simply picks up the thread from the thread pool, assign the work W and simply signal the thread. There is no pthread create API involved. Now why I am specifically emphasizing on pthread create API? Because this API is an expensive call. We will see in the next lecture video that why this API is an expensive call, but here you can notice that in this complete logic, there is no invocation of this API, right? There already exists a thread in the thread pool. The application simply pick up one of the thread from the thread pool, assign the work W to the thread and simply signal the thread, right? So a thread is placed back in the thread pool after it has completed its work. Now this makes complete sense. Your servants or your cars after being used are parked back to the garages, right? An application when initialized can create some predefined number of threads in the thread pool for later use, right? So the application which tends to use thread pool to implement its functionality can create some predefined number of threads, for example, let's say 5 threads in the thread pool only in the initialization phase, so that during the rest of the lifetime of the application may not have to invoke this pthread create API. It is better sometimes that only in the initialization phase, the application may invoke pthread create API 5 times, but after that, during the entire lifetime of the application may never need to invoke pthread create API because the threads are there in the thread pool for use, right? So this software pattern is also called as worker queue pattern. Here the threads which are parked or present in the thread pool work as a worker or queue threads on behalf of the application using the thread pool. So in this section of the course, we will going to implement thread pool functionality in our threadlib library, which we have been implementing in an incremental manner, right? So now in the next lecture video, let us discuss the benefits of thread pools.